Welcome back, everybody, to another deep dive with us. Today, we are heading out to Mars, or at least the rocks are. We're going to be talking all about NASA's Mars Sample Return Mission. The one with the Perseverance rover gathering those Martian samples, stashing them away.
Yeah.
But the real question here is, how do we get those samples back to Earth?
Well, that's the interesting thing. NASA has decided to defer that decision to the incoming Trump administration.
It's a real cliffhanger.
Yeah.
This move has fueled a ton of speculation. Some are saying it's a strategic play by NASA. Others are saying it hints at a larger shift in space exploration policy. What are your initial thoughts?
Well, I think the simplest explanation is that NASA wants the new administration, with a fresh perspective to weigh in on the funding and the mission architecture.
Sure, makes sense.
Seems reasonable on the surface, but this seemingly simple act really opens a Pandora's box.
I love a good mystery. So beyond that surface explanation, what are some of the deeper motivations that might be at play?
Well, some suggest it's a clever way for NASA to navigate a tricky political landscape. By handing off the decision during a period of, economic uncertainty and global competition, they could be shifting the responsibility and the blame if things go south to the Trump White House.
So if the mission succeeds, the Trump administration gets to celebrate a win.
Absolutely.
But if budget cuts or shifting priorities cause it to fail, the blame falls squarely on their shoulders.
Exactly. Minimizes risk for NASA. It could also be tied to the intensifying space race with China. Bill Nelson, outgoing administrator of NASA, he's publicly said, he doesn't want China to be the only country retrieving Martian samples.
Right.
And I think his comment speaks to that larger geopolitical game where, symbolism sometimes overshadows scientific goals.
Yeah. That adds another layer to the puzzle. So the Trump administration, they have a history of prioritizing speed and concrete results. So could this influence their approach to the Mars Sample Return mission?
Oh, absolutely. It wouldn't be surprising to see them push for a more commercially driven approach, maybe even leaning on private companies like SpaceX.
Yeah.
They're known for their innovative and often cost-effective methods in space travel. And even SpaceX's Starship has been suggested as a potential lander.
A Starship landing on Mars. Now, that's a sight I would want to see.
Yeah.
But wouldn't a commercially driven approach raise concerns about cutting corners or even sacrificing scientific rigor for speed and cost?
Valid concern. There's also the opposite worry that this delay is a way to quietly let the project just fade away due to budget constraints.
Oh, okay.
The Mars Sample Return Mission has already been criticized for its high cost. Estimates range from like $5 to $8 billion,
Wow.
depending on the approach. And further delays could make it very difficult politically and financially to justify continuing.
Especially considering that the Trump administration has shown a willingness to discontinue projects they perceive as too expensive or misaligned with their priorities. But amidst all this uncertainty, NASA has laid out two primary paths for retrieving these Martian samples.
Yeah, so they presented the classic approach using the Skycrane system, similar to what we saw with Curiosity and Perseverance. And then the other option is outsourcing that lander to a commercial partner.
So a tried-and-true method versus, I guess, a more agile but untested commercial option.
Right.
Could you break down the pros and cons of each approach and give us some insight into what makes them so different?
Sure. So the traditional Skycrane method, while it is reliable, comes with a higher price tag. NASA estimates it could cost anywhere between like $6.6 and $7.7 billion.
Okay.
The commercial option, on the other hand, is projected to be slightly cheaper, with estimates ranging from 5.1 to 7.1 billion. But, it's worth noting these are just estimates and actual costs could fluctuate.
Of course. I remember reading about JPL, NASA's Jet Propulsion Laboratory, and their potential role in either approach.
Yeah.
But haven't they faced challenges with cost overruns in the past? Like with some earlier versions of the Mars Sample Return mission?
That's correct. And JPL's past struggles with managing costs for complex missions like this, it raises questions about their ability to deliver on time and within budget, regardless of which path is chosen.
Right. Yeah.
And we can't forget SpaceX's own track record, while innovative, hasn't always been smooth sailing when it comes to deadlines and budgets.
So it seems like both options have their own sets of risks and rewards.
Yeah.
The Skycrane is proven technology, but expensive.
Yeah.
The commercial route's potentially cheaper, but you carry the risk of delays and potential cost overruns. It really makes you appreciate the challenge in front of NASA and the Trump administration.
Absolutely. And all this is happening against the backdrop of the space race. With China's Tianwen-3 mission aiming to retrieve Martian samples in a more streamlined grab-and-go approach, this adds another layer of urgency to the decision, as Bill Nelson's comment suggested that NASA's very keen on maintaining its leadership in this area of space exploration.
It's definitely a lot to unpack, but it's clear the stakes are high. We're talking about billions of dollars, international competition, and potentially groundbreaking scientific discoveries.
Yeah. Really underscores the complexity of space exploration. It's not just about the science, but the politics, the economics, the international competition.
Yeah.
But speaking of science, amidst all this back and forth, we shouldn't lose sight of why bringing back samples from Mars is so significant.
That's a great point. It's easy to get caught up in the drama. But at the end of the day, this mission is about scientific discovery.
Yeah.
What are some of the key scientific questions that these Martian samples could help us answer?
I mean, these samples, they're like time capsules.
Okay.
Holding secrets about a period in our solar system's history we know so little about. Studying them could provide insights into, how planets form, how their atmospheres evolve, and even the conditions that might have given rise to life.
So it's not just about learning about Mars itself, but understanding the bigger picture, how our solar system, maybe even other planetary systems came to be.
Exactly. And the knowledge we gain could have practical implications for future missions to Mars, including human exploration.
Oh, that's interesting. Could you elaborate on how studying these rocks could help pave the way for human missions to Mars?
Sure. Analyzing the composition of the Martian rocks and soil, I think, could help us identify resources that could be utilized by future Martian colonists.
Okay.
Think water ice, building materials, maybe even potential sources of energy. It's like scouting ahead.
Yeah.
Before we send humans to set up camp.
It's like a cosmic real estate survey.
Precisely.
Figure out what resources are available before you start building.
Exactly. And analyzing the samples could also shed light on potential hazards for human explorers. We can learn about radiation levels, the presence of toxic elements, other factors that could impact human health and safety, and allow us to develop strategies to, mitigate those risks.
So it's about understanding both the opportunities and the challenges of living on Mars long before we send humans there.
Exactly. And then, of course, there's the tantalizing possibility of finding evidence of past life. I mean, finding even microbial fossils would be monumental.
It would completely change our understanding of life in the universe. Even if we don't find fossilized Martians, this information could revolutionize fields like geology, chemistry, maybe even medicine.
Sure.
It's like having a pristine laboratory from another planet right here on Earth.
It's a unique opportunity to conduct research that would be impossible to do remotely. And we shouldn't underestimate the inspiration such a mission can provide. I mean, bringing back pieces of another planet, it's a testament to human ingenuity.
Yeah.
And our drive to explore.
It's a feat that could capture the imaginations of people worldwide, sparking a new generation of scientists, engineers, and dreamers.
Oh, absolutely.
But as we've discussed, it's not a simple yes or no decision.
No.
The financial and political factors are substantial.
It's a balancing act. On the one hand, we have the potential for these groundbreaking scientific discoveries and technological advancements, that could benefit humanity for generations.
Right.
On the other, we have to acknowledge these budgetary constraints and competing priorities here on Earth.
Some argue that the billions of dollars allocated to this mission could be better spent, addressing issues like climate change, poverty, or healthcare.
Sure.
It's a valid argument and one that deserves careful consideration.
Absolutely. It's a complex equation with no easy solutions. But it's through these types of discussions, weighing the value of space exploration against other societal needs, that we can reach informed decisions.
It's about finding a balance, investing in our future in space, while also addressing the challenges we face here and now. So, bringing this back to the Mars sample return mission, the incoming Trump administration has some tough choices ahead.
They do. And their decision will have implications not just for NASA, but for the trajectory of space exploration as a whole. What factors do you think they'll prioritize when making this decision?
Yeah, it feels like they're juggling so many factors: the scientific value, the budget, the political implications, even that global space race.
Yeah.
How do you think all those elements will play into their final decision?
Hard to say for sure. The Trump administration has shown a preference for those projects that yield, quick, tangible results, and they haven't really shied away from cutting funding for things they see as too costly or just not aligned with their priorities.
So the potential for groundbreaking scientific discoveries, even if they're, years or decades away, might not be their top priority.
Yeah, that's one possibility. I mean, they might be more inclined towards a faster, commercially driven approach, even if it means potentially compromising on some of the scientific depth of the mission.
Especially if they see it as a way to showcase American innovation and beat China in that race to bring back those Martian samples.
Exactly. But there's also a chance they could surprise us. They might recognize the symbolic importance of the mission, the potential for it to inspire national pride, and just cement America's leadership in space exploration.
It would be a bold move, considering the budget constraints and the other priorities they face.
It would. But it's not entirely out of the question. And let's not forget the ripple effects this decision could have on other missions, like the proposed Uranus orbiter and probe is on hold pending the outcome of the Mars sample return deliberations.
So the fate of multiple missions and potentially the future direction of planetary science at NASA hinges on this one decision.
Yeah.
It's a lot of pressure.
It is, and that's why I think it's so important for the public to engage in these discussions, to understand the complexity and to make their voices heard.
It's our future, too. We shouldn't just leave it to, politicians and scientists to decide.
Exactly. We need to think critically about, what we want our space program to look like, what kind of future we want to build in space, and how we balance those aspirations with the needs we face here on Earth.
So as we wrap up this deep dive into the Mars sample return mission, I think the biggest takeaway is that it's not just about rocks from Mars.
It's about so much more.
Yeah, it's about pushing the boundaries of human knowledge, inspiring future generations, and just making informed decisions about how we allocate resources and prioritize scientific endeavors.
Absolutely.
It's about understanding that complex interplay of science, politics, and economics in shaping our future in space. And ultimately, it's about asking ourselves, what kind of legacy do we want to leave for future generations?
Right.
What do we want our mark on the cosmos to be?
That's the question we all need to ponder.
What do you think the future of the Mars sample return mission should be? Share your thoughts with us in the comments, and don't forget to subscribe for more deep dives into the fascinating world of science and exploration.